All right, live from beautiful downtown Southern Maryland, it's time for Gears of Resistance, episode number 18 for the 8th of November, 2015. We're a bi-weekly podcast dedicated to bringing you the latest and the greatest in open source hardware news and tips and tricks for your DIY electronics projects, as well as some maybe a tip or two on running a business, little freelancing built on open source hardware. So that's that. We're coming off of 24 hours of gaming, so I may be a little tired. We did it's called Extra Life. Let me see if I can bring this up here. Boom, boom. Screen one. Does that look? No, let's do this. So Extra Life is a community. It's a nonprofit. It's a charity that helps raise money for the Children Miracle Network hospitals. I was playing for Johns Hopkins, since that's my alma mater, and so right now we raised about $6.3 million for 2015. That's going to go to again, depending on what team you signed up to play for. All those hospitals will be getting their share of the 6.3 million. Again, it was a way for the gamer community to kind of make a good name for itself, doing a little community service. So I was managed to raise $200. So thank you for everyone who donated, and yeah, that will be going to Johns Hopkins, which is just a few miles north of here. So with that, I guess it's time to get into the story. We've got the Slack channel up and running. We got a couple signups there. If you head to the website down over here, there's a little Slack community. You click on that. That'll give you a little sign-up sheet. And oh, that's not the Slack channel. I missed the wrong one. Anyway, you'll get a sign-up sheet. Give me about a day or two because I have to manually add you to the Slack channel, the Slack community, and then you'll be there, part of the GOR community. I guess let me just make sure that's the right link. Yeah, I messed up. I got to change that. Okay, I will have that fixed before this goes up. So anyway. Yeah, I'll save that for the last. So let's talk about this week. This week, we're talking circuit boards. So I'm just coming down off of a pretty big project that, for me, was the first time I actually had boards. Not just, usually I've done things where I have boards made, printed circuit boards, and then I will solder them myself. Usually a lot of through-hole components. Recently I've done a little bit with some bigger, larger surface mount stuff, but this project necessitated the need to actually go and work with a group over in China to actually get the entire board made, because there was no way I was going to be able to solder. So because of that experience, I saved and bookmarked everything that I used, every resource that I touched. And I'm going to highlight some of the more important ones for people that are maybe looking to do something similar, especially as you go from maker to semi-professional kind of work, where you may do something for other people. You can do your home brewed, you can etch at home, you can do some circuit with CNC machine milling. But when you're ready to do some professional grade work, you're going to have to go to a fab. I guess it's called a fab. I'm a chip guy, and they're called fabs. I think circuit boards are called fabs too. But anyway, you're going to have to get your board manufactured. Now, we'll talk about some resources. There's some steer. If you're in the U.S., I'm a U.S. guy. There's now resources where you can get boards made pretty cheap here in the U.S., but actually doing what's called a PCB assembly, or a PCBA, which is the entire board. So with the chips soldered on. So you have printed circuit board, which is basically just the board, no components. Then when you take the you take all your chips and resistors and whatnot, and you put those together with the board, but they're not soldered. That's called a kit, because you got the board and you got the components in the bag. And then when you solder them together, finally you get a PCB assembly, and then you put that into the enclosure and add the external stuff, and then you have actual a product or a good or something. Anyway, so with that, I'm going to try to make this a logical flow from tools to do your first schematic capture, to board layout, all the way through to getting it manufactured. So for doing schematic capture and board layout, there's a lot of options now, and a lot of really good ones and a lot of really cheap ones, like cheap being free. So the first one is KiCAD. That comes from I think it's CERN. So the guys over there in Europe that are, have the Large Hadron Collider, and they're spinning those little particles around and smashing them together. Obviously, they make probably a lot of custom electronics, because there's not too many people. There's not a huge market for Large Hadron Colliders. So because they're making tools for themselves anyway, they're sharing it with the world under I'm not sure. I think it's the MIT, but I could be wrong. I'm sure what open source license they're using. But the cool thing about it is, other than being completely free, is that there's a huge community and it's constantly growing. If you tried this a couple of years ago, it was probably a little quirky, but they were getting a lot better. It's really getting to the point where you can do some pretty amazing work with it, without pulling your hair out. And again, like everything with open source, there's a huge community behind it. Lots of libraries. And that's the hardest part with any of these tools, in my experience here lately with this last project, is just finding the parts. Having libraries of parts that you can just drop in the component when you're doing the schematic, and then having the footprint of that part when you actually do the layout, is huge. Like with this board I just did, there was, it looked like it was a little SO223, and that was how the library was built, but the chip was actually something different. But it was a struggle to find the part. The real point was it was a pain in the butt. I won't mention which tool I was using. But KiCAD, you get the schematic capture, which is drawing the circuit. And I guess for people that don't know, so schematic capture is like you're drawing the schematic. You're using schematic symbols to represent components. When you're done with that, that gives you kind of like the map. Then you take that and go to PCB layout, which you actually physically, now you're dealing with the actual footprint of how the part is actually manufactured. So, a resistor, a capacitor in a schematic doesn't look like how a real resistor or capacitor is in the real world. To make things easy, though, schematics use symbols. But then when you're ready to make an actual product, a PCB, you've got to actually deal with footprints of the actual device. And then the other nice thing is, it has a 3D viewer built in too, so you can look at your kind of what the board's going to look like. Again, all these rely on having good libraries, so that you have the symbol, you have the footprint for the layout, and then you have the actual part rendered mechanic. Looking at a CAD drawing of the part, so that when you do the 3D model, it actually looks like what you're actually going to get back from the fab. So that's KiCAD. If you're just starting off, it's probably the best one to start with, not just because of the cost, but because there's a huge community behind it. And I think community trumps a lot of other benefits of other tools. So with that, the second one, the kind of like the industry standard, at least in the world's the paths I walk, the people I deal with, is EagleCAD from CADsoft USA. Or at least CADsoft, I think CADsoft is, I think they're actually a German company. But I could be wrong. So anyway, they're up to version 7.4. Again, Eagle is the default. They do have a free version that's limited for maker private use. You can't do commercial work. But then like the first version that lets you have, well, you can do commercial work is, I think it's called their Lite, EagleCAD Lite. There's a lot of versions. That's the only issue with them. There's like a ton of different licensing agreements. So I think it's like 70, 80 bucks. You can do like up to like a 3x4 inch board, 2 layers, which is great for probably doing, a lot of people, if you're doing like Arduino shields or Raspberry Pi, whatever Raspberry Pi calls their shields. I think Capes is like for black beagle boards. You'll probably be just fine with that size. After that, though, it gets kind of pricey. You're talking a few $100s, and again, it depends on what like you want. If you want schematic and layout, which I think you kind of need both, but you don't want auto router, you can get a couple free. You know, it's a little cheaper. A word of warning for all these tools: I've never met or found an auto router that I like. So, you know, I always do manual, and sometimes it probably shows. It probably looks just as good as an auto router. And I say that facetiously. So you can save yourself a few bucks, you know, unless you're doing like 16 layer boards. But at that point, you're probably not doing kind of fun open source work. You're probably doing more professional grade, which at that point, it kind of just all goes out the window. This is all geared against people doing this kind of like semi-hobby, semi-professional. I probably say I use Eagle for majority of my work simply because a lot of the services that I deal with that we'll talk about later will accept a board file from Eagle to do the board design layout, and they're all the downstream services that I use to get a board made rely on Eagle. So that's kind of the reason why I use it a lot. There's also a great book from Simon Monk. He's got a Kindle version as well as you can buy it paperback. It's like 20 bucks. Making your own PCBs with Eagle, from schematic designs to finished boards. Pretty good resource if you're just starting out. All right, another cool tool, Fritzing. Fritzing is kind of it's got the vibe, the feel of the Arduino and processing community. But it's built to be, again, it's a circuit design, circuit capture tool. It also has a little bit it's built heavily, favors Arduino. It even has a simulator for Arduino, so you can actually lay out. Another cool thing about it is, before I get too far, whereas the other tools that we've talked about, you do a circuit, you schematic capture, then you do board layout. Fritzing relies actually on having real world physical models of their stuff. So you actually grab an Arduino board. It looks like an Arduino board. The resistors really look like resistors. And I'm trying to see if I can find, do they have like a little, everyone needs to have like a screenshot page so that you can, so we'll just use someone's project here as an example. Or maybe not. Parts, what are we looking for? So yeah, so parts library. So not only, again, there's not just the schematic symbol, there's not just the footprint, but they actually make well, let me do it. Let me just see if I can launch Fritzing, because I've got it downloaded. I used Fritzing a lot while it was. I use it a lot for educational things. So when I do classes for people that are just starting, for learning, especially schools, academics, Fritzing is really good for that. And I think actually I've got let me actually share my screen, not just the browser. So let me 1 second here. There we go. Let's share the whole thing. It's loading. nice thing about Fritzing is that it does a lot. So a lot of like the Adafruits, the SparkFuns, Seed Studio, companies that you're probably buying from if you're in that open source maker community, they do have a really good library. So here we go. They call it, let's see if I can launch one of my old projects I was doing. The breadboard view. So, like I said, they actually have, oops, you know, it looks like an Arduino Uno. It looks like an HC05 breakout board. It actually looks like a breadboard. So you can do this first, understand how things work, then move it over into a schematic, and then finally do, and I haven't started with the PCB layout with this guy yet, but it does the whole workflow from, and again, from someone who's just learning. If you want to be able to relate to the real world of how your real world items relate to your schematics when you're learning, Fritzing is hands down the best. It also, again, when you drop it in Arduino, you can actually put in code and actually simulate and run on the Arduino. Again, I don't do this for a lot of my work, but when it comes to classes and training, and especially like if you want to if you're interested in getting started with electronics, but you don't even want to spend the $30 on an Arduino board, this is kind of like the next best thing. You can have unlimited access to libraries of all these parts without ever paying a cent for them. You know, here's like a lily pad. So really encourage, if you're really just starting learning, Fritzing is pretty good. And again, there's another Simon Monk book, Fritzing for Inventors: Take Your Electronics Project from Prototype to Product. So again, this is actually, it's pretty cool because it's a book that's geared towards people that are, you know, yeah, you're a hobbyist, you're a maker, but you're actually maybe looking to do some small scale production to sell some products. So it's a really good book too. Boom, 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 boom. All right, last tool. As probably most people know, I occasionally do the blog posts for Mouser, though I don't work for them. So just full disclosure. But they do have Multisim Blue, which is based on the Multisim. Well, it is Multisim Blue. National Instruments, I think they just call it Multisim. But so here's the cool thing about this. It is free. They have a growing library. It does everything from, it does things that probably most of us, quote unquote, professional makers probably won't use. There's you can do simulations of parts. You can do kind of like systems engineering schemes of laying out your system, as well as doing the schematic capture, PCB layout. So very powerful, extremely powerful. And especially if you're going to college for this stuff, it's probably worth checking out, because it'll give you a good feel for kind of professional grade tools without having to pay, again, a red cent, which is nice. The other cool thing that is really nice, and this kind of transitions us into the next part of the conversation of it's one thing when you're just tinkering, making a design, having fun. Eventually, though, if you're really looking to actually make something, you're going to actually have to source parts. Multisim Blue, because Mouser is a parts distributor, first and foremost, it ties back in your bill of materials, which that's what we call the list of all the parts that are going to get soldered onto your board. That's your bill of materials. Multisim Blue can tie back into Mouser's database, and you can make your design, and you can see the price of what it, to make your board. You can see, is this part readily available? How many parts are there available? And what's the unit cost? And then you can basically start figuring out what it's going to what it's going to cost to manufacture your board. So that is really cool, versus the traditional way, let's say with Eagle, there's a tool, the user library program, ULP. Does ULP stand for user library program? Anyway, there's basically a little macro that runs, and it will spit out in Excel a little bill of materials. So when you're done, usually you take that, you export a bill of materials, you clean it up a little bit, and then you send it to your manufacturer, and they do the hunting for you, and looking for the parts. And then they come back to you with a quote. Here you can kind of get a feel for what it's going to cost. And again, if you're going to source the parts yourself and solder them, well, then right off that's the cost. I mean, obviously, if you're using someone to do this for you, they're going to do a little markup, so they make a little profit. But if you're going to make the board yourself and order the parts and solder them yourself, this is pretty cool. You'll know what it costs without doing a lot of additional work. It's built into Multisim Blue. All right, so moving on. Resources. So that's the tools, but now you got to learn how to use them. And there is a ton of resources out there. If you're just getting started, SparkFun Electronics, they're getting, according to Pete, video series with one of their, I think he's their lead engineer or whatever. He did 2 videos on PCB layouts, number 34 and 35. Highly encourage you to take a look at those. Those are really good to start with. Better than anything I could ever hope to do. That'll give you a feeling of, what are some of the design rules? What are some rules of thumb that engineers should take into account when they're designing boards? And so, and here's the thing, like a lot of times, in professional work, you may be an electrical engineer, you may do the layout, or you may do the schematic, but you may not actually ever touch the board layout, which that's kind of things that I've quote unquote suffered from. Is board layout was always handed over to somebody else. So I'm just as much learning good techniques on board layout, because again, it is a very specialized part of the electronics world. It's not just like traditionally in big companies, you're not the same person that does your schematic isn't probably going to be the person that does the board layout. So learning board layout, again, it's one of those, it's a practical skill that I think more and more should be taught in the academic world, not just coming up with circuits, but actually how do you make them into something that's actually manufacturable. So check out those. There's also, SparkFun has a good series called couple years back now, Better PCBs in Eagle. The nice thing is they provide a library for Eagle. You have design rules. So they provide the rules that they use for their rules checker. So when you make a board, you run DRC, which checks the physical aspects of the board layout, like is all the traces, are they the right thickness, do they have the right spacing between them? Then there's the ERC, the electrical rule checker, that checks to make sure that all the rat's nests are properly wired, and that every chip and that every wire and net between them is all correct. But those can be tweaked depending on what your comfort is, what kind of components you're using. But again, when you're just getting started, using SparkFun's default library for their rules is probably a good way to start. And it's really easy. You just download these files. When you install Eagle, there's the DRC folder. You just drop that file in there, and then tell Eagle to use that when you're doing any of your DRC checks. So that's pretty cool. And again, all the stuff, I'll have links to it, so if you're curious later, you can find it. Open Hardware Labs has a really good blog post again, for better or for worse, all this is built on Eagle. So even though I said, Fritzing is great, KiCAD is great, but here's the thing: a lot of the tools have their individual peculiarities, yes. But the design knowledge, the rules of thumb about good board layout are universal. So you can take this knowledge that you learn and move them across tools, yes, the intricacies of how you actually click this button or do this will change, but because probably a lot of people are making Arduino Shield seems to be the popular in vogue thing, this was a really good tutorial on how to do that using some libraries that are already out there. Again, I think actually, interestingly enough, they're using the SparkFun Eagle libraries, which I guess has the layout for a Eagle, or excuse me, an Arduino Shield. But again, like I said, there's a ton of resources, and I'm trying to put them all together. CircuitCalculator.com. All right. So how thick should a trace be? There's some other calculators here too, but Circuit Calculator 2, very, very simple, very basic. But this is a pretty useful little tool here, the little trace with calculator. You put in various inputs, so your thickness, your current, and then it'll tell you you know how you should be sizing your there we go, your traces, thicknesses, the widths. It's simple, but it does the job, and I'll leave that at there. Just the point, I was going to take this one out, but just the point is, when you're doing, the reason I wanted to put this in there, when you do through-hole components, that's one level of design. Dealing with surface mount introduces a whole another level of complexity, especially because the parts are so small that the normal, like for an LED, you'd always know that the shorter lead is the cathode, goes to the negative side. Surface mount, the LEDs, there's a couple different little mechanisms that let you know what side's anode, cathode. Point is, when you make the transition from through hole to surface mount, do some time to learn about how the components are different, how their markings are different, and kind of get a feel for the different sizes. If I'm going to do reflow at home, and actually this is pretty cool over here that you'll see there's the different, so like there could be a resistor, but a resistor could come in an 0603 size, an 0805, a 1206. 1206 is kind of like my personal threshold limit. I can try to do 805s, but again, I guess, you know, as you get older and your comfort level and your hands shake and your eyes aren't as good, you kind of find your tolerances. So the other cool, that's the other thing. Adafruit sells and I'll put that in the show notes, they sell a little ruler. Actually, let me bring it up here real quick. They sell a ruler that has, I think if you order like over like $100 worth of stuff, you get it for free anyway. So let me type this in here. Yeah, here we go. PCB ruler. And the cool thing about this is, let me bring this back over so I know where I talked about it at. It has every little component from integrated circuits to resistors, capacitors. They show you so that you'll know, you know, when you order a part and it's an 0805, this is how big it's going to be. So that's the actual layouts or footprints of various chips, and I think it's pretty cool. I keep this around with me all the time. All right, so we've talked about tools, we've talked about learning. Now let's talk about, like I said, the critical, difficult part is finding symbols, schematic symbols, and footprints, layouts for your layouts. There's 3 resources I found that are all pretty good. None are perfect, but they're all pretty good. The first one, let me actually bring it over here, is Octopart. The other cool thing about Octopart that they recently launched is a, let me see here, common parts library, both for prototyping and manufacturing or production. So when you're just starting out, like there's like crap ton of parts and stuff out there, and you want to build a board. What they've done is they've gone through, they've looked at all these different designs and all these boards out there, and they said, in general, these are kind of, the general kind of parts that are out there that you can order. They're the most common. And they do it for everything. So displays, relays, linear integrated circuits, digital integrated circuit, resistors, potentiometers. So what you can do is, when you're out making a design, you can kind of get a feel for, okay, if I'm looking for a 10 kilo ohm resistor plus or minus 10%, well then a Bourne's 3362P-1-103LF will cost me about $1.02 from DigiKey, and I think there's everybody's here. So when you click on the part, actually, yes. When you click on the part, here we go. You get access to everybody that's selling this part. There we go. So, okay, I know I wanted a 10K potentiometer. Here's Newark, DigiKey, Vertical AvNet, Online Components, Master Electronics, Mauser, Arrow, Allied. You can see what's in stock and what my unit cost is going to be. One of the big things that people should know is, if you didn't know, is that buying in bulk definitely has its advantages. So let's pick on Newark here, for example. This part, if you buy just one, is going to cost you $1.02. If you buy 10,000 of them, the unit cost is going to be basically 44 cents per. So you're going to save, it's going to be over half of the cost when you buy in bulk. Now, if you're doing a board and you're doing a layout and you're looking to sell them, and this is kind of like you're like, it's a prototype, you kind of know there's a market there for it, you should probably be targeting at least 100 units. So in your mind, plan on buying and selling 100 units. If you can do that, then basically it's a lot harder to go from your first sale to 100 than it is to go from 100 to 10,000 sales, because you probably, if you sell 100 things, there probably really is a market. So your first goal should always be 100 of whatever gadget widget you're selling. That's just kind of like a rule of thumb that I've learned through dealing with these manufacturers overseas, is that when you start talking 100 units, they start, prices can start being a little bit negotiable. At least that's what I found. So Octopart, that's one where, again, their common parts, look for their common parts library. It's a really good resource if you're just getting started. You're like, oh my God. Like if you go go into like Mauser or DigiKey, you type in resistor, and it's like, there is 5.6 million, results. You're like, where do I start? This tool, kind of gives you a place to start, and it's pretty cool. Boom, boom, boom. So let me close that one out. So the other one, again, same idea, is SnapEDA. So like if I type in, let's type in 555, because everyone knows a 555 timer is one of those magic components. It will go through and it's going to look and it's going to search and it's going to find all these different designs that use a 555 timer. And did I type something wrong? Let's try 555 timer. And you can filter by things like, if it's in stock, is it lead free, does it meet the European environmental kind of compliance stuff. So same thing, here we go. Okay, so there we go. Texas Instruments. Let's see here, the LMC 555. Now again, because you're searching, Octopart, the common parts library, does a nice thing where it walks you through, say, it's here, this is what people use in general. If you go to SnapEDA, you're going to have to know what kind of specifically what part you're looking for. But the nice thing about that is you can get the CAD parts. You can download not just the symbol, but the footprints. You can get the specs on the part. You can look at pricing across, again, all the different sellers out there. And there's a little kind of like, this one doesn't have it, but you can have like a little forum about that specific part. So that's pretty cool. The last one I haven't used as much, not just because I didn't want to, they're bad, it's just because I haven't, you know, there's only so many hours in the day. But I wanted to throw it out there because it was pretty good. And that's parts.io. Let me put in 555 timer in here. And wow, does it give you some information. So it tells you here we go. So we'll scroll down. So it kind of does like the snapshot of how you can filter down on things. So basically, do you want something that costs this much or up to this much? What's your what kind of package do you want? And then it filters that down here, where you can again start looking at different prices, different manufacturers, and get access to spec sheets and everything else. So that's parts.io. If there's anyone else out there that there's other stuff that I'm missing that would make my life easier, I would love for people to let me know too. All right, so that kind of helps you understand the boards, the parts, where to find the parts, what parts should I be using. Then you've done your design, you've picked out your parts. Some things, there's some other tool I found is called 3D Board Viewer. Again, other tools have this built in. Eagle, I think you can get it. It's a costly add-on, or you can just take your board file, throw it up on 3dboardviewer.org or .bg, scitech.bg. Not sure. But you can upload your board file, and they will have a I'll take one of their examples. Boom, boom, boom. They will have you can do an online 3D board. And I'm not sure why it's not showing the green. I think it's a problem with my browser, not their website, because all the files have done that after a recent upgrade. But I wanted to throw it out there. It is a resource if you want to do 3D views of your board when you're done. All right, moving along. Let's talk about the manufacturers that you have access to. If you're looking to just make boards, oh wait, I should do bill of materials first. No, let's wait. So if you're looking to just do a board, OSH Park, they're made here in the U.S. Really good prices, really fast turnaround. You can pay for even faster. They do 2 and 4 layer boards. 2-layer boards are $5 a square inch. 4-layer boards are $10 a square inch. That's for 3 copies of the board. Let me see here. Let me bring up one of my projects. So here we go. Let's do this guy here. You upload the board file. It does this automatically. It automatically creates their if I click on it. No. So it has all the files. It makes all the files that it needs to manufacture your board simply by uploading the board file. And I've done this a couple times, and it works tremendously. The boards are really high quality. The only caveat I would throw out is it's kind of like Henry Ford when he released the Model T, that you can get your board any color, that your favorite color, so long as your favorite color is, in this case, purple. It's kind of like their signature trademark, so that if you look at a board and it's this color purple, you know it's an OSH Park board. For some people, that may be a deal killer. For me, I think the price outweighs that. I know there's some people that like different color. They make their colors, their boards different colors to, like, you know, red as a prototype, green is a production model, yellow is R&D. And like, I understand people have color codings for different reasons. But if you're not married to that, OSH Park is really good, really cheap, really fast. Like this little board here, let me see here. How much did it cost me? $7 for 3 boards, so less than, you know, just over $2 a board. I like them. Now, again, with OSH Park, they're only going to give you the PCB. You're going to have to solder on your own components yourself. With that said, so let's talk about, this is really what was kicking my butt here the last couple months, is building a bill of materials to send to someone overseas to actually manufacture the board, to give me a PCB assembly. The people that make the Photon, Particle.io, they have a freaking fantastic blog on bill of materials. And they even like show an example of one of their how they do their bill of materials. I have since taken it and used it as a template for some of my work. Tweaked it a little bit for meeting my needs, but it is a fantastic article on how and why bill of materials are important, and I cannot agree with them more based on this last couple months of experience. It's the board itself, because the tools, you know, are kind of now kind of universal. Making the board is really easy. Explaining that I want this particular chip on this particular footprint, oriented in this such a way, the polarity of my LEDs, that kind of stuff comes down to good bill of materials and making sure that you are using your silk screen on the board to lay out. That's some things that I've learned, that my second iteration of the board I'm making now, I got to go back in, do a better job of making the polarities, like on LEDs, very easy for people to be able to just look at the board and go, yeah, that's the polarity, by just simply looking at the board instead of having to go pull up the design file. Second part, though, is the bill of materials. Is make sure that there is no ambiguity into the numbers of parts, where the parts go. And like I said, this blog post absolutely nailed it. And I think you should read it. If you're just getting into, if you're looking to actually send the bill of materials over to actually someone to make, it's pretty good. So let me turn on the fine folks at, so the people I used, I finally, after like more research than I would have liked to have done, because I've never, again, I'm a very small shop. Pretty much it's me. Every now and then I reach out to people I've worked with to kind of like, you know, subcontract out some little things. But it's always, you see, a lot of times, not always, it's a lot of times it's just software, and I try to do all the hardware myself. Some of these little chips I had to use in this latest project, like I sneezed and they would blow away and I couldn't see them again. Almost, I mean, like, it's getting pretty ridiculous how some of these small these chips are. I went through PCB Assembly Express. I know that the fabrication is actually being done overseas, China, more than likely. But the people that I dealt with when they had questions about my design files, they were in California and Washington State or Portland. Or they were either in Oregon. Yes, Oregon, basically West Coast, right? These were phenomenal people. They were very nice to work with, very easy to work with. And I felt like they, they actually were, when they looked at the boards, they understood the issues. They could look at, oh, that's a good board, that's a bad board. They made recommendations. They worked as much as they could to fix issues. They were very communicative. I was probably actually the worst one on not communicating fast enough. I mean, I would get emails at, midnight, 1 a.m., which is, 8 or 9, 10 o'clock West Coast time, about, hey, we're missing, it looks like you have 3 LEDs on your board, but you say in your bill of materials you only need 2. They obviously they were taking it serious. They were looking at the board, comparing the bill of materials, and it showed. And I can't recommend them enough. Like I said, it was a really good experience, and maybe there's other people that are better or cheaper. I don't doubt there's better. There may be cheaper, but I think the cost was really fair, really reasonable, given the fact that I was doing such a low volume and yet expecting things to happen so fast. PCB Assembly Express was pretty good for me. All right. I think that in a nutshell was all the things I wanted to kind of talk about in terms of getting your board made. Now, I think next, when I get these boards back, maybe we'll talk about, how you spin a board up, how you go through testing it out, making sure that, and how you do it in small incremental steps where, you don't try to make the, the most complicated part on your board work first. You want to first toggle some LEDs and then work up from there. So maybe we'll talk about that next. With that, do you want to get some feedback on some ideas? So this week, the new James Bond movie came out called Spectre. It was a great movie, by the way. I really liked it. I thought they took a Sean Connery era story and made it work for the modern day realism grittiness that was a staple of Casino Royale, Skyfall, to a lesser extent Quantum. But I think it was like, again, a really classic James Bond storyline made to deal with the realities of the real world today. So I really, really liked it. I know some people say, well, it's not quite as good as Skyfall. I actually, it's kind of weird. I actually didn't like Skyfall as much. I thought it was a very good movie. I didn't get the feel it was a James Bond movie. Maybe that's the old fart in me talking. But this one was like, this is a James Bond movie. And not only that, was a very well done, and it was real, and it was gritty, and it was true. It was not the campy of the Roger Moore era. It was, even the Sean Connery era was quite absurd in some of the storylines. But with that, so if you haven't seen Spectre or you're on the fence, I'd say go see it. It is a great movie. But in the last movie, in Skyfall, they introduced finally Q again. And in this movie, in Spectre, he reappears, and he's definitely more of a character than Desmond Llewellyn, who was the guy that played for Q for like forever. Not to take away from his performance, but Q actually gets a little bit more. He's got a role, and actually all the characters, Moneypenny, Tanner, M. There's much more of a feel that there's a team behind the one-man 00 wonder. So anyway, QBranch. So it got me thinking, and I had been toying around with this idea already. I didn't have a name for it, but in my little side business, Green Shoe Garage, again, I'm a one-man, two-man shop, depending on the day of the week. And I like it that way because it's not my day. It's not my main job. I don't want to have employees. It is a freelancing gig. I like the freedom of freelancing, but I can't begin to. There's so many projects that come my way that either I can't. I just don't have the time. I mean, there's a lot of cool projects that people have said, "Hey, can you help me build a board to do something?" I'm like, I would love to. I'm already swamped. I've got the day job. I've got the family. I've got other hobbies, and then I'm doing this part-time. I just can't get to. I would love to do your project, but if you could wait 12 months, 6, I could maybe get back to me. I can, or it's a project where I don't. I'm not an expert. I'm not good enough on whatever said topic. A lot of times it's like apps. Everybody wants a smartphone app. The apps I do to support my hardware are very clunky, not sexy. So anyway, long story short, turn away a lot of business. And I've got a lot of friends that probably who I think are looking to do freelancing. More and more, I think that's becoming, especially for tech science people, technology people, engineers, freelancing is a way to, you can make a little extra dough on the side. But I think a lot of people, it's satisfying that itch. I'm not getting that satisfaction because a lot of day jobs, it's you're building things, you're designing things because you have to, not because you want to. And this is a way to. So anyway, QBranch is the tentative kind of name for a. I'm not sure what it's going to be. It's not. I don't want to make it just yet another social media site. Not a LinkedIn, but the idea is there's a lot of people out there that have projects they need someone with skills to do. There's a lot of people with skills out there looking for something fun to do and looking to bring those two groups of people together. So you can kind of read what the idea is. Basically, the tagline that I have is that your organization may not be a clandestine, super secret government organization, but you probably do need, you do have a need for the access to the types of brains and skills that the QBranch offers their fictitious secret agents. So the idea is, I'm not sure what it's going to be yet, and this is where I'm hoping to get some feedback from people, but I do want to build a sort of collaborative network, a community, a network, and not just software, not just electronics hardware, but there's scientists out there. There are technicians out there. There are mathematicians out there. There's even artists out there that are, I think. So basically, the idea is we do the Steam Power podcast too. So the people that have STEAM skills, and then there's people out there that need access to those types of people on a part-time, per gig basis. How do we link that world up? And that's where this idea of a QBranch is born. It's kind of like a freelancing QBranch. So anyway, that's it in a nutshell. A lot of more work on the idea to come. I think, though, I like it. I think it could be really helpful and really useful. Just need to figure out more of how to implement it. So if you've got ideas for something like this, please pass them along. And then if you visit greenshoegarage.com/Q, eventually we'll have a sign-up sheet there for people that are interested. Working on that now. Anyway, I think that is it. God, I have talked a lot. This is a long one. Boom, 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 boom. Yep. That's all good. Okay. So with that, head over to gearsofresistance.com where you can get links to everything else we do. Sign up for the Slack channel, and I'll links to everything we talked today about doing a circuit board. I'll have links to all that. Every story, every site we showed, I'll have that up there. And then, of course, the biggest thing is, like I said, done a lot of circuit design, have never really done much professionally on board layout. So if you're out there and you're someone that you're watching this and you're shaking your head going, let us know. What are your recommendations? What are your resources? What are your tips, tricks, tools to doing board layout, especially geared towards people that are, you're doing this kind of for fun, but maybe looking to do it kind of, semi-professionally, at least as a freelancing side gig. So you can share those and we'll put those out to everybody. Again, the best place to do it is join the Slack community. All right. So with that, thank you all very, very, very much for listening. I think that is everything. Yep. So until next time, I can't say keep it steamy, and I want to have something for like that, but keep it steamy, stay quirky, and thanks for watching. See you next time.